rapidly evolving domains, that is on deep learning. This field has transformed industries from healthcare and cybersecurity to autonomous systems and natural language processing, and continues to open new possibilities for research and innovation. And a short introduction about our today's guest. To guide us through today's sessions, we are honored to have with us Dr. G. Kripavati, Assistant Professor at the Amritha School of Physical Science, Amritha Vishwa vidyappetham, Coimbatore. She holds a PhD in cybersecurity from Anna University, with her doctoral research focusing on botnet detection using machine learning. Her expertise spans cybersecurity, network intrusion detection, IoT and IOOT security, ransomware and malware analysis, and of course, deep learning and explainable AI based solutions. Dr. Kripavati has published her work in reputed international journals and conferences and also contributes as a reviewer for IEEE journals and conferences. Alongside her strong research contributions, she is deeply committed to mentorship and technical innovation. We are truly delighted to have her with us today, and I look forward to an insightful session on lead learning. Let us all warmly welcome Dr. Kripavati to lead today's discussion. Madam, now please continue the session.
Thank you, sir.
Thank you.
Good evening to all. Myself, Dr. G.Kirubavathai. I'm working as an assistant professor at Amritha Vishwa vidyappetham. Let's start the session. So, today we will explore how two of the most exciting areas of artificial intelligence, such as deep learning and computer vision, in education, how they are reshaping the education landscape. We will see what they are and how they connect and how they are applied in classrooms and assessment aspects. Deep learning and computer visions are revolutionizing the educational landscape from smart classrooms to secure online assessment. These AI technologies enable personalized learning, efficient content delivery, and automated monitoring, making education more interactive and scalable and secure. So, so here is the roadmap of today's session. We will begin with the basics of deep learning to set the foundations and ensure everyone is aligned on the key concepts. Next, we will move to the basics of computer vision, which deals with how machines can interpret images and videos. After covering the fundamentals, we will explore how deep learning and computer visions connect, showing how neural networks power the most modern vision applications. Once the technical ground is set, we will shift to applications in digital classrooms such as smart attendance, engagement learning, tracking, and then discuss applications in online assessment, focusing on exam security, automated grading, and proctoring. We will also review small tools in education which faculty can adopt without needing advanced coding skills. Finally, we'll critically reflect on the challenges and ethical issues as such as bias and privacy and responsible usage before wrapping up with future directions where we will envision how these technologies may transform teaching and learning in the coming years. This agenda ensures we move from fundamentals to applications to the ethics and futures, giving a balanced view of both opportunities and responsibilities. So let's start with basics of deep learning. Deep learning is essentially a specialized branch of machine learning. It's inspired by how the human brain processes information. Instead of relying on human to define rules and features, deep learning uses multi-layered neural network to automatically learn patterns from the raw data, whether that is images or text or speech. So the key distinction between deep learning and machine learning are the deep learning learns features hierarchically, which means deep learning you have multiple layers of hierarchy. Lower layer captures simple elements like edges in images or letters in text. Middle layers starts combining those into patterns like shapes and symbols. Higher layer extract abstract concepts such as recognizing face, understanding a topic, or interpreting handwriting meanings. This hierarchical representation is what makes deep learning so powerful. It learns increasingly complex patterns without manual feature engineering. So, what do you mean by deep learning? Yes, before diving deeper, let's first clarify. deep learning actually, what deep learning is actually. At the broadest level, we have artificial intelligence. This refers to any technique that allows computers to mimic aspects of human intelligence like decision making, problem solving, or perception. With artificial intelligence, we have machine learning, which is a subset that focuses on algorithms trained on data. Instead of programming explicit rules, machine learning enables systems to learn patterns from experiences. Now, deep learning. Deep learning is a specialized branch of machine learning. It is inspired by how the human brain works, particularly through artificial neural networks. The key idea is that deep learning models consist of multiple layers of neurons, allowing them to learn progressively more complex features from raw data like images, speech, and text without needing the manual feature engineering. So, this diagram helps us to clarify, understand the hierarchy of artificial intelligence, machine learning, and deep learning. At the outermost circle, we have artificial intelligence. The AI is a broad concept of creating machine that can sense, reason, act, and adapt, essentially mimicking the human intelligence. Inside AI, we find out machine learning. Machine learning represents a subset of AI where systems can train on data. The key point is that their performance improves over time as they are exposed to more data. Instead of manually coding all the rules, machine learning learns patterns directly from the experience. Finally, at the core, we have deep learning. This is the further specialization of machine learning that uses multi-layered neural network. These networks can progress vast amount of data automatically and extract hierarchical features, making them extremely efficient for tasks like image recognition, speech processing, and natural language processing. So, how deep learning works? The deep learning works by trying to replicate the way humans analyze informations and draw conclusions. Just like we process sensory input, compare it with past experience, and then make decisions. Deep learning algorithm constantly analyze data with logical structure to extract meaning. The key mechanism behind this neural network, which is built on multiple layers. As we saw in the previous slide, it has an input layer, hidden layer, and output layer. So this diagram represents the structure of deep learning neural network. On the left side, we see the input layer labeled as X dash, where the raw data enters into the model. For example, the X can be an pixel value from an image or words from the text. This circle represents an input features. This circle, inside the circle, these circles represents hidden layers. So these hidden layers will work with weights. These W1, W2, and W3, these are all the weights that determines the strength of signal being passed forward. As the model Altogether, as the model trains, these weights are adjusted to minimize the error. This will be the first hidden layer. The first hidden layer may detect very simple patterns like edges in the images. And the second hidden layer builds on that, detecting shapes or structures. And deeper layers combine these patterns into more abstract concepts such as recognizing a face or identifying a handwriting digits. Finally, the right, you have output layer, which gives you the prediction, for example, classifying whether the input is a cat or dog. This multi-layered weighted structure, this will be the weighted structure, is what gives deep learning its power. It learns progressively complex representations automatically without the need of handcrafted rules. So this is where deep learning excel than the machine learning methods. So this diagram illustrates the key difference between machine learning and deep learning. At the top, machine learning, in machine learning, the process is split into two stages: feature extraction and classification. In feature extraction, the humans must carefully design and select the important features. For example, if we want to classify whether an image contains a car, an engineer would extract features like wheels and windows and edges, etc. These are all the features belongs to car. This classification, this here the machine learning algorithm then uses those features to classify the object, whether the object is belongs to car or not car. In the contrast, the deep learning at the bottom of the image of this diagram eliminates the need of manual feature extraction. So the neural network itself perform both feature extraction as well as classification. The neural network itself performs feature extraction plus classification together. It automatically learns the patterns like edges, shapes, and eventually the whole object directly from the raw data. This is why deep learning scales so well for tasks like image recognition, speech processing, and natural language understanding. It reduces human intervention and leverages large dataset to learn features on its own. So the key idea is that the central idea of deep learning is that it can automatically extract hierarchical features from raw data without requiring manual programming. In traditional machine learning, experts have to spend a lot of time designing features such as selecting what patterns or attributes should be measured. For example, in handwriting recognition, engineers would explicitly define features like stroke, width, curve orientation, etc. In deep learning changes this completely. In the neural network learns features layer by layer, starting from simple edges or shapes in early layers and progressing to more complex patterns and abstract representation in deeper layers. This ability this ability to automatically learn representations in what makes deep learning so powerful. So, if we connect with this with education, it can automate grading. For example, recognizing handwritten answers or analyzing essays. It can recommend content by learning what materials are most effective for different learners. It can enable adaptive learning system where teaching adjusts automatically to the strength and weakness of each student. In short, deep learning reduces the burden on the teachers and makes learning systems smarter and more personalized. So the key idea, the traditional machine learning, in case of traditional machine learning, it required manual feature engineering. Experts have to decide what features to extract. Where in the case of deep learning, extract hierarchical features automatically. So in the the main functionality of deep learning, you have multi-layer neural network. In multi-layer neural network, the layers will progressively extract the features from the raw images. So we'll see deeper examples how this deep learning more relevant to education. First application of deep learning is automated grading. One of the most direct application of deep learning in education is automated grading. For scanned answer sheets or diagrams, the convolutional neural network, CNN is nothing but it is a convolutional neural networks are commonly used. W- while transformers can applied for essays of can be applied for grading long answers like essays. So the CNN can recognize handwritten math steps and compare them with the model solutions, not just with the final answer. This helps evaluate whether the student approach is correct even if made the small calculator error. Similarly, CNN based systems can grade multiple choice questions by reading scanned OMR sheets quickly and accurately. For real world deployment, companies like Google have developed tools like AutoML Vision, which help train to recognize handwritten characters even in local languages. This is particularly useful in multilingual education context where grading system must be adapted to diverse script. The value here is not just time saving for teachers but also greater consistency and fairness in grading since the system applies the same evaluation criteria to every student. So next application of deep learning is content recommendation. Here the models often use recommender system based on embeddings. A common technique is collaborative filtering powered by neural networks. Especially the system learns patterns from a student past activity, what lecture have they have watched, what questions they have answered correctly or struggled with, and uses these informations to predict what material will be most useful next. For example, a student who struggles with a specific math concept may automatically receive extra practice questions or simple video explanation before moving on. On the other hand, advanced learners may get challenging exercise to push their skill further instead of repeating what they have already known. Real world platforms already do this. Coursera and Khan Academy uses AI driven or recommendation engines to guide students through their learning journey, offering tailored resources that match their pace and level. The advantage here is that deep learning makes education personalized and adaptive, ensuring every learner receives the right content at the right time, much like having a personal tutor. So, third application of deep learning is adaptive learning systems. So, in adaptive learning systems, platforms like that dynamically adjust the entire learning experience to suit individual students. Unlike static courses where everyone follows the same sequence, adaptive systems analyze student performance in real time. They consider the factors such as response accuracy or students getting correct answer or making repeated mistakes, response time, or they answering quickly, showing mastery or hesitating or indicating uncertainty, engagement signal. Do students spend more time on certain topics, skip ahead too quickly? Based on these signals, the system adapts. Struggling students receive step by step guidance, hint, and foundational material to reinforce learning. Fast learners offered accelerated modules or advanced challenges so that they motivated. The examples of such systems include platforms like Dreambox Learning, which personalizes lessons in math and reading K-12 learners. The big advantage of ad- adaptive learning is that it makes classrooms more inclusive. Each learner gets a pathway tailored on their strengths and weaknesses, much like having a teacher who can individually coach dozens of students simultaneously. So, next applications of deep learning is accessibility applications. For students with visually impairments, deep learning models can perform real-time text-to-speech conversion during printed or digital text into audio. Similarly, image captioning models can describe diagrams or figures, allowing visually impaired learners to engage with courses materials more fully. For students with hearing impairments, deep learning based speech to text systems can provide live caption during lectures. This makes classroom discussion and video lectures more inclusive. Language accessibility is another important use case. Neural machine translation models can automatically translate lecture notes or subtitle in local languages, breaking down language barriers in education. Real world examples include tools like Microsoft Immersive Reader and Google's Live Transcribe, which apply deep learning to improve inclusivity. The so why the matters in education? The first is scalability. One deep learning model can grade thousands of script faster than a team of teacher. Yes, exactly. Personalization. Every student can get a custom tutor powered by deep learning. Accessibility removes barriers for differently abled learners. Efficiency. Teachers can focus on higher order tasks like mentoring, critical thinking, while deep learning automates routine ones. So next we'll move to basics of computer vision. Computer vision is a branch of artificial intelligence that focuses on enabling machines to see, interpret and analyze visual information from real world such as images, videos and live camera streams. It bridges the gap between raw pixel data and meaningful insights, allowing system to understand and act what they observe. So, in simple analogy, just like our eyes capture the light, our brain interprets the objects, and computer vision system converts raw pixels into features into objects, objects into decisions. So, so this will be the simple explanation of computer vision. So, on the left, we start with a pixel. It is an image; it's nothing but a grid of pixels. This black and white are various shades of colors by themselves. These pixel the next comes with the processing step. This is nothing but it's a number 2 in the grid form. The next comes the processing step where the neural network analyze these pixels. The network detects patterns like edges, curves and shapes and gradually building up from low level details to higher level features. Finally we get insights. So we'll see what are all the applications in computer visions in education. The first application is image recognition. So image recognition is about classifying an entire image into a single label. For example, determining whether an uploaded picture is a essay, response, or diagram submission or lab setup. How it works? A neural network analyzes the entire image and extract features like edges, structures, and shapes, and then assign to the most likely category. Example in education. Schools and universities can automatically classify scanned answer sheets, for example, separating math assignments from essay responses. In digital learning platform, image recognition could identify whether a student has uploaded a diagram for science class or lab experiment photo. Sir? So next application of computer vision is object detection, which takes computer vision a step further than the simple image recognition. What is it? So, object detection not only identifies the object or present in an image but also locates them, usually by drawing bounding boxes around each other. It combines classification with localization. For example, detecting not just that the student is present in the classroom, but exactly where they are in the video frame. So, in a classroom setting, the object detection can be used to detect raised hands in the video feed, making it easier for teacher to track participants in larger group. In lab environments, it can ensure safety compliance by checking whether students are wearing required gear such as goggles, gloves, or lab coats. So, next applications of computer vision is segmentation. Segmentation divides an image into meaningful regions, giving pixel level understanding instead of just bounding boxes. This helps machines not only identify objects but also separate them precisely from their background. There are different types of segmentation, semantic segmentations and instant segmentations. How the segmentations will be useful in education? Separate teachers' handwriting from the whiteboard background to create clean digital notes. Isolate diagrams from scanned answer script for automatic grading. So next applications of computer vision is optical character recognition. Optical character recognition is the process of extracting text from images, photos, and scanned pages or converting into a editable digital text. This OACR combines computer visions with sequence models. First, the system detects characters and words from the raw pixels and then it reconstructs them into the meaningful digital text that can be stored, searched, and edited. So, why these technology techniques matters for education? The first one is image recognition objects. So, image recognition will help to automate classification of assignments and exam scripts. In case of object detection, will enhance classroom engagement monitoring and exam pattern. And segmentation provides clean, digitized teaching materials from machine inputs. Optical character recognition bridges the gap between paper based and digital learning environments. So applications, how these deep learning and computer visions will helpful in applications. Digital classrooms. So the in digital classroom, it capture and clean lecture notes and analyze engagement. Assessments, online assessment, it will scan and grade answer sheets with OCR. Then proctoring, detect additional persons or device in exam environment. Accessibility, help visually impaired students by reading out text from images. These are the main applications of deep learning and computer vision. How deep learning and computer vision works together? How it's related to each other?
Madam,
So yes, sir.
madam, we
Sir.
shall ask that whether the faculties are, madam, we can ask faculties whether they are clear till now
Oh yes, sir.
about the
Please. Oh
subjects what
sure,
we
sir.
have go through.
Yeah. Sir. Audience, do you have any doubts, or can you able to follow me? Whether is it clear to you,
Dear
audience?
faculties, kindly give me your feedback
Yeah, faculties, please.
because we are, I don't know whether they are following us or not. Okay, okay, fine, fine.
Yeah. Thank you.
Yes, madam.
Thank you,
So
Madhubala.
faculties,
Yes,
if we
thank
have
you.
any doubts till now, we can ask. That you were
So,
clear till
so
now?
far, I will give you some gist. So, we'll see for machine learning. Machine learning, how the machine learning differs from deep learning. In case of machine learning, we need to give features for training the model. In order to learn the model, we need to give the features. We need to extract features from the images or text or whatever it may be. Where in the case of deep learning itself will extract the features from the images or text or speech. This is the main difference between machine learning and deep learning. So when you will go with machine learning, if you have a features in your hand, if you have a data set is nothing but features, you can go with machine learning in order to train the data, in order to get prediction or classification. When you have a raw images, raw data, you don't have any features. So in that case, definitely you go with deep learning. So raw data is nothing but, here the raw data is nothing but our students or classrooms or whatever it may be. So we have a raw data. So how we will classify, how we can go with this? So ultimately we have to go with deep learning concepts. Is it clear? So next, uh, yes, faculty sir, are you comfortable? Uh,
Faculties, your feedback is very important for us.
yeah. So then
We
one more
don't.
thing. Yeah, one more thing. Actually, deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. Yes. So everything is will be the subset. So deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. Yes. How the artificial intelligence works? It will works mimics the human brain. Artificial intelligence. It works based on the mimics the human brains. How deep learning? Deep learning, it will work purely on deep neural networks. Neural networks. What do you mean neural network? Neural network, you have a multiple layers. So you have an input layer, hidden layer 1, hidden layer 2, hidden layer 3. Then you have followed by, you have one output layer. What do you mean by input layer? This input layer are the features extracted from your raw images. Okay, so these input layers will be multiplied with weights into, it will move into the hidden layers. The hidden layers will extract features from your raw images. Then the next level hidden layer will fine tune the raw features. And likewise, the if n number of, based on your application specific, you can have n number of hidden layers. The final hidden layers will give you the prediction or classification. So this concept can be applied into the educational domain, where we can perform online assessment, online teaching and everything. That's why this deep learning and computer vision nowadays, deep learning and computer visions is important landscape in educational domain. Is it clear? Yes, sir. Shall I continue, sir? Shall I continue? Do you have any doubts?
Faculties, kindly make it as an interactive session, please.
Yeah.
Yes, ma'am.
Have any doubts,
Continue.
please feel. Yeah, thank you. Thank you. So, how this deep learning and computer vision works together? So, deep learning is an engine, provides powerful learning algorithms, where in the case of computer vision is the eye, supplies raw visual data to be processed. Yes. So you can think the deep learning as an engine. It provides a powerful algorithm that derive learning and decision making. And computer vision as an eye, it supplies the raw visual data like images and videos that need to be processed. Together, they form a complete system. The eye captures information, the engine interprets and learns from it. In fact, modern computer vision is almost entirely powered by deep learning. The techniques like face recognition, OCR, object detections, all rely on deep neural networks to achieve their current state of the art accuracy. With deep learning, computer vision, without deep learning, computer vision would struggle to scale beyond basic image processing. And without computer vision, deep learning would lack one of the richest sources of data, that is visual world. Is it clear? Yes. So, what are all the models, deep learning models is used in computer vision? So the first model is convolutional neural network. These are the backbone of the computer vision. This CNN model is the backbone of the computer vision. This CNN are designed to detect edges, structures, and shapes and objects in images. They work layer by layer, starting from the low level features like lines and edges, gradually moving toward full object recognitions. The next DL models are recurrent neural network, long short term memory, and transformers, while CNN handle still images. These models handle sequences, making them perfect for video analysis. They allow us to recognize action over time. For example, detecting whether a student is raising hand, writing on a board, or engaging a group activity. The transformer is in particularly are now take up or in sequential tasks, including vision language models. It's nothing but have you heard about large language models? NLP, natural language processing, and these are all the applications of deep learning. Nowadays, the NLP and vision language models are the most applications of deep learning. So next model is generative adversarial networks. So generative adversarial networks are used to generate synthetic images and data. This is useful in education because data sets are often limited. For instance, GAN can create realistic handwriting samples or diagrams to train grading systems and improving accuracy without needing thousands of real examples. Together, these deep learning models cover the full spectrum, image, videos, and even data generation, making computer vision much more powerful and adaptable to educational needs. Is it clear? These are all the sequential model we can apply it on natural language processing. RNN, a transformer, LSTM, these are all the sequential models. Yes, shall we move to the next slide? Are you comfortable with the previous one? Yes, we'll see with an example. Now, what we have seen, how the deep learning and computer vision connects. Let's talk about actual models that make this possible. First, we have a convolutional neural network. These are the workhorses of computer vision. They are excellent at detecting edges, structures, and shapes, which build into an object. So, whether it's recognizing handwriting, digit, or detecting object in a classroom, see or go to the model. The second is handwriting for handling sequence of images. For handling sequences of images like video frames, we use RNN, recurrent neural network, LSTM, long-term transformer model, or more recently transformers. So these models add ability to track changes over time, making them essential for tasks like action recognition. For examples, detecting whether a student is raising their hand or whether engagement levels are dropping. Finally, we have GAN, generative adversarial networks. These don't just analyze, they create. So the GAN network can create. GAN are widely used to generate synthetic data, which is extremely valuable in education, where labeled data may be limited. For instances, GAN can generate extra handwriting samples or diagrams to help train grading systems. So in short, CNN help us to see, RNN and transformer help us to understood motion, and GAN help us to create more training materials. Together, they make computer vision far more powerful and flexible. Is there any doubt in this slide? Is it clear? Is the slide is clear? You want me to repeat?
No, madam, clear, madam.
Thank you, sir. Thank
You
you.
can
Sir.
continue.
Okay, sir. So next we'll see applications in digital classrooms. First application is attendance. Imagine a teacher walking into a class and instead of spending 10 minutes calling out names, a smart camera powered by deep learning instantly recognize each student's face and marks them present. No proxy attendance, no wasted time, just a smooth start learning. So second applications is engagement monitoring. Think of how challenging it is for teacher to track attendance in a large class. AI can detect subtle cues like raising hands, facial expressions, or even gaze direction to show who is engaged and who may be falling behind. It acts like a digital assistant, giving the teacher real-time insights. So third application is Lecture notes digitization. Many times students miss a point written on the board. With OCR and segmentation and handwritten content can be automatically converted into clean, shareable notes. This ensures that every learner, whether in class or online, has equal access to the materials. Fourth is adaptive learning. So in adaptive learning, every student learns differently. AI systems can track interactions and suggest personalized exercises like offering and extra practice to one student while providing advanced platforms to another. It's like giving each learner their own private tutor. Finally, accessibility tools. So, real captions, text to speech, and translation for inclusive classrooms. So, these are all the some of the applications of digital classrooms which is given by deep learning plus computer vision. Is it clear? Yes. We'll move to the next slide.
Yes,
Audience.
madam. Yes, madam. Next
Thank you.
slide.
Yeah, thank you, thank you. So as we saw in the previous slide itself, how the automated grading work in deep learning. So in the case of automated grading, traditionally grading answer sheets, whether multiple choice or descriptive or diagrams, with AI OMR sheets, the MCQs can be recognized instantly. Even handwriting recognition now allows descriptive answers to be graded automatically. For science and maths, computer vision models can recognize diagrams and evaluate against expected patterns. This saves teachers enormous time while ensuring consistency. Next application is AI-powered proctoring. Online exam face the challenges of impersonation and unfair practices. With multi-face deduction, the system can flag if someone else is sitting in the place of candidate. The computer vision can able to detect security devices like phones or second screen that might indicate cheating. The third applications of online assessment is integrity analytics. So AI doesn't just monitor during the test, it's also analyze the answer patterns afterwards. For instance, if two students show you unusually similar responses, or if someone answers with suspicious speed, the system can flag anomalies for review. So finally, scalability. So what once required dozens of yeah, sorry. So AI driven grade.
Someone is not unmuting, ma'am.
Shall I continue, sir?
Yes, ma'am.
Yeah. In summary, AI, artificial intelligence in assessment ensures not just speed, but also fairness, transparency, and integrity in online assessment. So, small tools in education. After exploring the classrooms and assessment, let's look at some of the small tools that are reshaping education. First, immersive readers. Tools like Microsoft Immersive Readers use deep learning to provide to speech, translation, and highlighting. Imagine a student struggling with English. Now they can hear the text spoken aloud or even translate it into their own language in real time. This bridges learning apps instantly. Second is AI tutors. These are intelligent chatbots and recommender systems that guide students just like a personal tutor would. For example, if a student makes repeated mistakes in algebra, they can suggest additional practice problems or video lessons tailoring support to their exact needs. Third is lab safety monitor. In science or engineering lab, safety is crucial. The computer vision can monitor whether students are wearing personal protective equipments like gloves and alert if someone is missing. This ensures both safety and accountability in learning environment. The fourth one is content recommendation engine. Just like Netflix, just like Netflix recommend us movies. AI can recommend learning materials. Platform like Coursera and Khan Academy already personalize course suggestions based on interest and phase and performance, creating individual learning pathways for every student. And finally, AR VR classrooms. What do you mean by AR VR? So
Audio,
AR VR is
audio
augmented
visual.
reality Augmented reality, virtual
virtual.
reality. Yeah, exactly. Yeah. So this, imagine medical students practicing surgeries or engineering student exploring 3D imaginary inside a virtual lab. With computer vision, enhanced simulations like augmented reality and virtual reality make abstract concepts come alive in safe and immersive environments. Together, these tools not only extend the boundaries of classroom but also makes learning more personalized, engaging, and practical. So next we'll move to what are the challenges and ethics while will face while using deep learning and computer visions in education. So bias in AI models, yes, definitely there will be some bias, unequal performance across genders, languages, or regions. Yes, AI systems often reflect the biases present in the data that they are trained. So, we need to train the AI model properly. Then only we can get accurate results. If we are not trained the model properly, it will lead some bias. So, the second one is privacy concern. Continuous monitoring may raise surveillance fears among students. So, when it comes into privacy concern, many AI tools rely on continuous monitoring, such as cameras for attendance and engagement. While useful, this raises valid fears of surveillance can affect how comfortable students feel in the class. Yes, exactly. So we have to consider this also. When it comes into third challenge is data security. Storing sensitive student data, it creates cyber security risk. Definitely, the hacker can able to intercept your data. So the fourth one is reliance on AI. If teachers begins depending too heavily on automated system, their role risks being reduced to supervision than the mentorship. AI should support, not replace the human connection in education, right? It should not replace the human. So finally, transparency. The automated grading and decision-making system must be explainable. Students and teachers should be able to understand why a certain score was given, why an answer was flagged. Explainable AI is crucial for fairness and trust. Sorry. Yes, is it clear? So these are all the challenges and ethics we have to follow while using deep learning and computer visions in education. Shall I move to the next slide? Yeah. Audience?
Yes, ma'am.
Yeah, thank you. So in future, the first future direction is federated learning in education. Instead of collect all student data in one place, federated AI allows models to train across multiple institutions without centralizing sensitive data. This ensures privacy while improving accuracy across diverse learning environment. Second, explainable AI, making grading and feedback interpretable to both students and faculty. Cross-model learning, instead of speech, text, and video, and handwriting for holistic assessment. Fourth one is real-time feedback system. AI detects student confusing during lectures and prompting teachers' interventions. Sustainable AI. The last one is sustainable AI. Here, energy efficient DL models suitable for large-scale education deployment. In future, the AI in education is not just about automation. It's about privacy, fairness, inclusivity, and sustainability. If we get this right, technology will truly empower both learners and teachers. So these are some of the references which I have referred for this presentation. So thank you. By equipping faculty with AI-driven teaching strategies and research tools, this FTP future create efficiency and academic challenges. So thank you. Thank you for your patience. And if you have
Madam,
any queries, you can ask.
yes, yes. We give you time. If you have any
Yeah,
queries, you can ask.
yeah, please. Not only this PPT, if you have any doubts related to academic, teaching, research, whatever, you can ask freely. Yes, sir. Yes, whatever doubt you have, please ask. I will ready to answer. If I know, definitely I will answer it. Please. Any questions? At least one or two questions. Whether is it useful? Whether you have learned some few words, few technical words from this FTP. Audience, faculties.
Faculties don't have
Anything.
any
Eh,
questions. Faculties,
Thank you,
kindly
Prabhu.
make it as an interactive session, please.
Yeah.
Ma'am, very
Any
useful, ma'am.
question? Yeah, thank you, Prabhu sir. So anything related to teaching, learning, or anything related to deep learning, or anything related to computer vision, or anything related to machine learning. If time permits, in future I will take I will take the deep learning from the scratch. Okay, how the deep learning models works in depth. Okay, I will take one project and I will work it out and I will let you know
Hello,
if
ma'am.
possible.
So,
Yes,
shall
yes,
we
ma'am, please.
conclude this session?
Hello, ma'am. Hello, sir. Can I
Yes,
ask a question, sir?
yes, ma'am, please, ma'am.
Ma'am, I'm trying to do a research in PCOD detection, ma'am.
Okay,
Ma'am, how can we collect data and images for that? That is my PhD. I have tried doing it that. I didn't do any
okay.
initial work on that, ma'am. How to work on that? If you have any inputs on that, you can help me, ma'am.
Ma'am,
PCOD
PCOD.
detection with the
Okay,
images of those files. How can we detect whether it is possibility of PCOD or not?
yes, you can,
That
madam.
is my
Madam, you can detect if you have a pool of corpus of images with PCOD or some normally the PCOD with PCOD image and without PCOD image. You can train the model by using RNN or CNN. These are all the very basic models for images. Okay, ma'am.
okay.
So you can try with these two models. Definitely, you can get the results, ma'am. Then RNs, you can combine the models. You can combine with RNN with LSTM, CNN with BiLSTM. Likewise, you can combine also. If you have any, if you want to continue with this, please contact sir. He will guide you, ma'am. Sir,
Yes,
if
madam.
any,
Yes.
if you need further help means you personally contact sir, ma'am. We will help you. Okay,
Sure,
ma'am.
sure.
So thank you because
We are providing, we are
how
providing
to
that
gather the
services also,
accurate
ma'am.
images, ma'am. How to find the accurate images of PCODs. In online, we don't get accurate images. How do we get that, ma'am?
There are in foreign universities there are n number of depositories, image depositories are there. We have the link. You please contact sir. We are providing that kind of services also, ma'am. Yes, sir.
Sir,
Yes, ma'am.
your
Yes.
email ID, your contact number can we provide, sir? We don't have the details in the WhatsApp group or in the email to contact, sir.
Yeah, yes, sir. Sir will give you, ma'am. Yeah, everything. If you need anything related to research or you need any help, please contact sir. He will guide us, ma'am. Definitely, we will help you, ma'am. No
Thank you so
problem.
much. I require
Yeah,
a help
thank you.
from your side, from the sir side. Please share the mail IDs or contact numbers so that I can connect with you, ma'am.
Sure, ma'am. Sure, ma'am.
I,
We'll help you, ma'am.
I think everybody have our things scholar publishing mail ID, so you can ask your questions or whatever queries to that mail
Yeah.
ID.
Okay, sir.
Yeah.
Yes, ma'am. It's possible. Your research idea is good, ma'am. Research problem
Okay.
is good. We can
Okay,
work,
ma'am.
ma'am. No problem.
Thank you, ma'am. Thank you, ma'am. Thank you.
Yeah. Yes, ma'am.
Any more queries?
Please, if you have any doubts.
If you have any research oriented doubts, you can just ask the ma'am.
Yes, you can. Will actually we are providing research services also. Yes, sir.
Yes, ma'am. Yes, ma'am. Surely.
Yeah. You have any doubts related to writing the research paper, how to implement the research, how to find the research problem in specific domain, how to write a research paper, how to find a specific journal for the your research, and how to publish a paper, how to write a paper, how to write a response to the reviewer's query, how to
Ma'am,
submit the paper, everything.
ma'am,
Yes,
take
sir.
a class about how to write a basic research paper, ma'am.
Sure, sir. Sure, sir. Definitely, we will conduct, sir.
Next time, kindly conduct, ma'am.
Yep, sure, sir. Sure, sir.
Okay,
Definitely.
ma'am.
Yes, sir.
Basic idea about how to
Definitely.
beginners for,
From the
for the
scratch.
beginners from
Yeah,
the scratch,
definitely.
ma'am.
Yeah. How to
Yes, ma'am.
collect the literature review, how to
Yes,
find out the
ma'am.
research problem. From that research problem, how to find the literature paper articles related to your research problem. How to find how to find your research problem from that existing article. Then how to write, how to implement your research problem. How you will write up your paper. How to convert your results into your research paper. Everything will cover, sir.
Yes, ma'am.
Yes, sir.
Faculties can post. Yes, the faculties can post your questions to my mail, and we will get back to you. We have 1 more minute, so if you want to ask any questions, please. Otherwise, we can conclude the session.
Any time சீக்கிரம் படிச்சிட்டோம்.
I think it's a very big exam.
Sir, sir, please share your mail ID, sir. They are asking, sir.
Yes, yes, sure, sure.
Okay, sir. Sir, if anything related to your research, we are providing research services also. If you need any help, please contact sir. We will help you. We will ready to help you.
Sure, sure, sure.
Any doubts, any queries?
Okay, madam, I think we can conclude the session.
Yes, sir.
So, on behalf of Think Scholar Publishing and the Asian College of Engineering, I would like to thank Dr. G. Kripavati ma'am for her insightful and engaging session today. Your lecture was not only informative but also gave us a deeper understanding of the topic, which will surely guide us in our future work and research. I also extend my gratitude to all the participants who joined from across Tamil Nadu and contributed to the interactive discussions. Your active involvement made the session even more meaningful. Once again, thank you, ma'am, for taking the time to share your expertise with us. We truly appreciate your valuable inputs. Thank you all. Thank you, everyone. So, if you have any doubts, kindly I have given the mail ID, and also I am giving my mobile number also, so you can ask
Yes.
any doubts. Yeah.
Yeah. Thank you so much
Thank you.
for everybody for your patience, and thank you once again. If you have any doubts, please let me know. Thank you for your presence throughout my session. Thank you. Thank you, sir. Shall I
Thank you.
leave, sir?
Yes,
Yeah.
madam. Yes, yes.
Thank you, sir. Thank you, sir.
Everybody can sign off it. Yeah.